Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, this is your chemistry class, and today the topic is the covalent bonding, which we are discussing. This is part 2 of it. Covalent bonding. We were working on the covalent bond actually, right? So we discussed about the single, double, and triple covalent bond. The common examples which you all know about them. That's the example of the ammonia. Everywhere you can see single covalent bond is there. Okay, so if you check ammonia, you can find that if someone is waiting, please join down like that. Okay, you can see that single covalent bond is there here, here, and here. How many electrons are there in one single bond? 2 electrons are there, so total 6 electrons are being involved in it. Okay, and if you focus here, there is a double covalent bond. Okay, now there will be 2 dots and 2 crosses. So this is a double covalent bond, right, between oxygen and oxygen. You can see boron trichloride, a single covalent bond, single covalent bond, and single covalent bond. You can see the dot and a cross here, dot and a cross here, and dot and a cross here. So this is a single covalent bond. In case of nitrogen, you can see dot and a cross 1, dot and a cross 2, and dot and a cross 3. So there are 3 pairs of electrons which are connected. So you will find a double covalent bond here, a single covalent bond, a single covalent bond, and triple covalent bond. Okay. Okay, one thing which we need to understand is which bond is stronger, a single, double, or a triple bond. So triple bond is much more stronger because there are 3 connecting points. Okay, so if I take hydrogen connected with another hydrogen, this is a single connecting point. Oxygen with another oxygen, 2 connecting points are there, and nitrogen with another nitrogen, 3 connecting points are there. Okay, so the more the connecting points, the shorter is the distance between them. Okay, so triple covalent bond is much more shorter. Keep this in your mind. But one problem is there. If you have a single covalent bond between 2 molecules and you have a double covalent bond between 2 atoms, right? So which one is going to be reacting first, the single covalent bond here or the double covalent bond? So the double covalent bond will be reacting. Double covalent bond will be reactive. It is more reactive, and I'll tell you the reason for that. And if there's a triple covalent bond, then the triple covalent bond will be reacting much more quickly. Okay? Are you getting the point?
Yes, sir.
Okay.
Yes, sir.
So,
And I got the point of the covalent.
Can you turn off your mic, please? If you're talking in private, I should not hear you. This is the dative covalent bond which I talked about in the previous class also. You can see here, dative covalency. I told you this is the dative covalency. Okay, you put hydrogen with it. Another example of the dative covalent bond is, this is a combination. Ammonia and boron trifluoride, when they combine together, they make a dative covalent bond. I need to focus on this area. I want your attention here, please, everyone. And I want that you should focus here on it, okay? See, look into this now. This is a dot cross, and a dot cross. It is a single covalent bond. The same way, dot cross and a dot cross and a dot cross. They're all single covalent bonds. Okay, normal covalent. But you will see something different here. And that something different is 2 dots are there. Who is providing these 2 dots? Can someone tell me who is providing these 2 dots?
Nitrogen.
Nitrogen from ammonia is providing these 2 dots. And to whom it is providing? To boron. If you focus here now, you can see that there is an arrow directing from nitrogen to boron. This is a dative covalent bond. Now, what is the difference between the normal and the dative? The normal covalent bond is a 50-50 sharing, and the dative covalent bond is a 100-0 sharing. Number one. Number two, it does not make any difference in terms of adding and removing electrons. Like the electrons stays the same in number. If you count these total electrons, 1, 2, 3, 4, 5, 6, okay? 6 electrons are there for boron. And for nitrogen, 1, 2, 3, 4, 5, 6, 7, and 8. 8 are still for nitrogen. The only difference is that before you were counting these green ones for nitrogen only, now you're counting for boron also. Boron is sharing now. Boron was having a deficiency of 2 electrons to complete its octet. 8 electrons completion. Every element in the periodic table go for completion of 8 electrons except helium and except hydrogen, because helium is having 2 electrons and hydrogen is copying helium. So in this way, boron is now thinking those 2 electrons are with me also. So when you count for boron, you count 8 electrons for boron and you count 8 electrons for nitrogen. It doesn't make any difference to nitrogen, but it does make the difference to boron because you are now counting 8. Any question?
No, sir.
Okay, I'll provide you my notes, okay? No problem with that. So don't worry about it. Now you can see the structure of ammonia, once again ammonium ion. Once again, this is ammonium ion right in front of you. Okay, so this is ammonium ion, and one of the hydrogen you can see. This is the pair of electrons which is not dot and cross. It is just provided from one side, right? Okay. Now one thing more. What is aluminium chloride? Is it ionic or covalent? Aluminium chloride in your course. What is your course telling you about aluminium chloride? Is it covalent or ionic? AlCl3, aluminium chloride. Is it ionic or covalent?
Ionic.
Okay. In grade 10 you were studying it's ionic, but it's totally different and opposite of that. Let us see aluminium chloride now, and let me share with you the white screen, the whiteboard now. I want to draw aluminium chloride for you. Where is the whiteboard? Here it is. You can see my whiteboard, right? Is it visible to everyone?
Yes, sir.
Okay. So now aluminium chloride is AlCl3. Aluminium chloride at low temperature exists as AlCl3. At high temperature it exists like this, and at low temperature it exists like Al2Cl6. This is called di, yani 2 MERS units. It's called dimer. The structure of this dimer is a part of your course. I will draw its dot cross structure of aluminium chloride. Now we were thinking that aluminium will lose 3 electrons and chloride will accept each electron 1 and it will make ionic, but it's making a covalent compound in reality. So how does it work? Let us see this part now. This is the structure of aluminium chloride. You have Cl, Cl, Cl. Okay. How many electrons are there in every chloride? 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Every chloride will go like this: 1, 2, 3, 4, 5, 6, and 7. Okay, and then 1, 2, 3, 4, 5, 6, and 7. Then 1, 2, 3, 4, 5, 6, and 7. Right? 1, 2, 3,
Yes.
4, 5, 6, and 7. And how many electrons aluminium does have? Single electron, and single. 3 electrons are there in every aluminium, right?
Yes, sir.
Okay, aluminium is in group number 3, so 3 electrons. Chlorine is in group number 7 of the periodic table, so 7 electrons are there. Now there will be a combination: single covalent, single covalent, and single covalent. Count these electrons. How many do you see now on this aluminium, the shared one? 2,
6.
2, and 2. So total electrons are 6 now. How many more this aluminum can accommodate? 8, right? I need 2 more electrons. Okay, this one now, and this one. How many more this aluminium? Each aluminium can now accommodate still 2 electrons. So those 2 electrons will come from which side? These 2 electrons will be provided to this aluminium, and these 2 electrons will be provided to this aluminium. Right? When I am drawing the arrow with the electrons, it's dative covalent. Dative. And this one is normal covalent. Are we clear with this?
Yes, sir.
So if I want to draw the structure just only with lines, this is the dot and cross diagram, okay? And if I want to show just only with line, how will I draw this? Let me remove everything once again and see if I can. Okay, I'm just removing. Okay, okay, okay. Let us remove all the electrons and let's just leave only the lines for it. Okay, now see, normal covalent, normal covalent, normal covalent, dative covalent. Okay, normal, 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 and dative. Are we clear with this?
Yes,
This
sir.
is the structure of dimer. You will be asked about it. To draw the structure of dimer, how you are going to draw it? Again, focus on how did I do that? Going into the very beginning, 2 of the aluminiums are there. Okay, keep them at the same distance. Then one Cl in the middle of those 2, and the other Cl at the corner here. Then Cl, Cl, and Cl. Now simple, simple, and simple covalent. Simple, simple, and simple covalent. Done. Now go towards the dative. Dative covalent, dative covalent. If you want to complete the structure with all the dots and crosses, you can complete it then. The structure will go complicated. Okay, now let me put all the electrons now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'll put the 7th one later on. 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. Okay, now the dot and the dot here, and put the crosses for aluminium. Cross and a cross and a cross. That's it. Okay, one dot is still left. Here is one dot. Now count all the bonding electrons. How many bonding electrons do you find here? You will find one pair. Okay, one dot is still left here. Second pair, one dot is still left on the other side. I didn't put that dot. Okay, third pair, fourth pair. Why the dots are running away from me? The dot. Okay, fifth pair, sixth pair, seventh pair, and eight pairs of electrons are there. How many pairs of electrons bonding? 8. How many total? 16 electrons are involved in bonding. This structure is called a dimer. Dimer is a composition of two monomers, two small units together. So when we are dealing with aluminum chloride at lower temperature, it is existing as Al2Cl6. Okay, Al2Cl6, that is existing at lower temperature. It is in the solid state, and at high temperature it is in the gaseous state, and it will be always AlCl3. It is covalent. Don't consider as something different. It's covalent. If you have any question